In this video, we're going to talk about power, Ohm's law, and passive sign convention. So in your physics class, you probably learned the formula that power is equal to I times V, the current times the voltage. However, I want to tell you right now that is not quite true. They were lying to you a little bit back then. And it's because it depends on how you've decided to direct your current and your voltage. So if we have a simple resistor here, there are 4 different scenarios that we could label things. Now, I want to make clear that in all 4 of these situations, we're going to apply the same voltage source in the same fashion. So all of them are going to have the exact same thing physically happening inside of them. They're going to have the same current actually moving inside of them. They're going to be absorbing the same amount of power and so on. So the physical side of it is going to happen the same in all 4 of these. However, what's going to change is how we are labeling what's happening. Now again, we're not changing what's actually happening, we're just labeling it. So in the first one, we're going to choose to label the voltage with the positive on top, and we're going to choose to label the current as going downwards. Now again, when I put I and put my arrow down there, that doesn't mean that current is actually flowing down here. Current might be going the opposite direction, in which case the value of my I would be negative. But we don't care, we're just labeling it this way. And you have a positive or negative I. In the second one, I will go ahead and label my voltage the same way, but I will label my current going upwards here. In the third one, I will label my voltage with positive on the bottom and current going down here. And the last one, my voltage is on the bottom and current is going up. So this is the 4 ways you might label your resistor. Again, the actual physical thing that's happening here, let's say we're all going to hook them up to a 9-volt battery or something, that's going to be the same, and how you connect it is going to be the same for all 4 of these pictures. And what that means is that physically, again, everything is the same in all 4 of them. It's just the mathematics of how we're writing them down and calculating them is going to be different. And again, just to make our life easier here, let's go ahead and say this is a 1 ohm, so then we know that it's going to be 9 amps going through here. Now, for this first circuit here, as we said, we know it's going to be 9 amps going in this direction, so that's what's actually happening. So that means since the I drew is the right direction there, I is going to be 9 amps. And the voltage here is going to be the 9 volts. It's the same across the 9-volt source as well as the resistor because they're in parallel. Now, similarly here we have, in this case, because my I is going in the opposite direction from what this label here, so it's actually going this way, the label's opposite, then if you were to measure the I in that labeled direction, you would get a negative 9 amps. However, your V is still 9 volts. Again, next one is 9 amps here, and we labeled it down, so I is 9 amps. However, because I chose to label the V in the opposite direction, it's still parallel, but it's in the reverse orientation. So if you were to measure it in that way, you'd actually get a negative 9 volts. And similarly, this last one, my I is going to be negative 9, and my V is going to be negative 9. Now, if you were to calculate the power in each one of these scenarios here, you see you're going to get different answers. And that should not be happening because the difference between a positive and a negative power is whether the item is absorbing the power from the circuit or it is delivering or creating the power for the circuit. And a resistor is never ever going to be creating the power for the circuit. resistors only absorb power, which means these negative powers here, they don't make sense. And so what we talk about is we say if you have passive sign convention, that is going to be any scenario where you label the current going into the plus side of the voltage for that element. So in this case here, it's the first scenario and the last scenario. All right, the first and the last here, if I number these 1, 2, 3, 4. So 1 and 4, those follow passive sign convention. And whenever you follow passive sign convention, then your power is I times V. However, if you do not have passive sign convention, that would be 2 and 3 up in here. 3. As you see, in this case, the plus is coming, the current is coming out of the positive terminal. Maybe I'll write that here. So current into plus side, and this is going to be current out plus side. And whenever that's the case, then your power is negative I times V. And remembering whether you have a negative sign or not is going to be pretty important, because imagine all the times in your life you've solved math equations, and if you put a wrong negative sign there, guess what? It messes everything up. Same thing here. If you put the wrong negative side, or you put the negative sign where you're not supposed to, or vice versa, it's going to mess up all your calculations. And you might say, who cares? Power, we always know resistors, power is going to be positive, so it doesn't matter. And you might say, well, okay, well, power, the sources, well, they should always be delivering, right? So it's all power for a source is negative. And by the way, up in these pictures here, in all 4 of them, if you look at this, we have the 9 volt, and we had a 9 amps coming out of the positive side. So it's the negative IV scenario. And yes, it is in fact delivering power there. That's what the negative power means. However, I want to say that it is definitely possible for you to have a battery that is, instead of delivering power, it's absorbing power. So you could have, in fact, a positive power on a battery. And you might ask, well, how is that possible? Well, imagine you're charging your cell phone, right? There's your battery that's gaining power there. That would have a positive power here. So just because you know it's a source doesn't mean it's going to be positive or negative. You have to just actually check it, and you need to follow these rules. And even worse, it's going to cause even more problems for you, because we won't actually deal with power all that often in this class, is Ohm's law. You've all heard V equal to I times R, right? That's your Ohm's law. But this is actually only if passive sign convention. Whereas if it's not passive sign convention, you have to actually use V equals negative I times R. And we are going to be using Ohm's law over and over and over and over again in our problems. And so it's very easy to get mixed up on minus signs in this case here. So just remember, passive sign convention, you don't have to worry about these extra negative signs. And so basically, if you have a circuit and they haven't labeled pluses or minuses everywhere, then I would go ahead and choose to label my pluses and minuses in order to follow passive sign convention. Because if you don't, you have to worry about these extra negative signs, and it just makes it more likely that you're going to make a mistake somewhere.